Good morning to all. Today we discuss about the topic electrostatics. This is the first chapter of physics. First of all, know what do you mean by static? Static means rest. Electrostatic means it is a branch of physics which deals with the study of charge which is at rest. See, here we study about the charges which is at rest. Not only charge, the force experienced by the charge, the field, electric field created by the charge, and the potential drop occur due to this charge. This all we study in this chapter. First of all, we know what is charge. Charge is made up of atoms. What is atom? You all know. It has a central part called nucleus. The outer part it is called electron. Nucleus contains nucleons, means proton and neutron. Proton is positive charge and neutron is chargeless. Okay. These proton, neutron, electrons. These are the fundamental particles. You all know. In 10th class, you also know. This is a magnet, this is another magnet. It has two poles, south and north. It has also two poles, south and north. North-south get attracted, but north-north get repelled. How this is possible? Because the magnet has some intrinsic property. It has some inner property. That's why it can attract the opposite pole and repel the same pole. Similarly, the charge has same. If the positive charge, it can repel the same positive charge, but it can attract the opposite, means negative charge. Means proton attracts electron and proton gets separated. Okay, clear? See, attractive repulsive. These are what? These are the force. See the definition. It is the physical property of matter that causes it to experience a force when placed in electromagnetic field. Means, means if there is some electromagnetic field, if you place a charge, then it can create a force or it can affect the electric field and magnetic field. Second definition says, one property of force, it exerts electric and magnetic effect. Some electric and magnetic effect is caused by this charge. Also, definition, it has some intrinsic property that creates force. Due to this charge, it can create a force. It may be attractive or may be repulsive. We already discussed about the charge. Now we discuss the property of charges. The first one is additive property. Means if a system having a number of charges, that is Q1, Q2, Q3 or Qn, then the total net charge is equal to the summation of all individual charges. Means this is a system having Q1, Q2 up to Qn. This is a system having number of charges. Then the total charge Q is equal to Q1 plus Q2 plus up to Qn. This is the additive property of charges. Second one is conserved charges. Means conservative property means charge can neither be created nor be destroyed. It can transfer from one to other system. Means see, in an isolated system, here all the charges are equal. At that point the charge is Q, in this point the charge is Q. Means isolated system having a same quantity of charge in all the points. Next, third point is, one is additive property, then conservative property, quantization of charge. Quantization means calculation of charge. How we calculate the charge? See, this is a system having number of charges. What is the total charge? Q is equal to Q1, Q2. If suppose there are n number of electrons, means I write it n into Q. If charge is electron, then n into E. Okay? Q is equal to n into E. See, this is called quantization of charge. This is n is not a fraction. It's only a whole number. 0, 1, 2, 0 up to n. Okay. We already discussed about the charge. Then now we discuss how this charge can be created. There are three processes: by friction, second by conduction, and third by induction. First of all, know friction, second one is conduction, third one is induction. Okay. See, friction. Friction means you already know in first year you discuss about friction. If two bodies are moved with each other in opposite direction, they create friction. Means rubbing two bodies. See. Okay. See, this is a neutral body. Neutral body means the net charge equal to 0. Means the summation of positive charge and negative charge is equal to 0. Means number of positive charge equal to number of negative charge. This is the neutral body. If I place another body nearer to it having positive charge, see, this body having positive charge, it closes to the body, to a neutral body. Then what happens? See, this is a positive body. This positive molecule, see, this is proton. Positive means proton, it can attract the negative. See, this attract the negative towards itself, and the rest are just repel to each other. Plus repel to each other. That's why plus is goes to here and the minus is goes to here. Negative ion comes to closer and positive ion goes to here. Okay. Next test. If I connected it to the ground means zero potential. In the next session, I will discuss what is potential. Okay. See, this is zero potential. The rule is the charges are moved from high potential to the lower potential. See, these positive ions, they are moved to ground. Only the body negative charge. Okay, only the body having negative charge. See, if I move this positive, okay, if I move this positive body, then only the body having negative charge. Two bodies, then the heat is produced. Similarly, when two electric particles we rub with each other, then electron can move from one body to other. The body which receives electron or which gain electron is called negative, and the body which donate electron or it can release electron, that is called positive. Okay. See, by friction, if two bodies rubbing with each other, then one body give electron to the other. In this way, charge can be created. Second, conduction. Conduction means the physically contact. Your mobile, okay, if your mobile having discharge, then what are you doing? You take the charger and connect it. The charger and mobile physically connected through the wire. That is called conduction. Means physically contact with each other. But in induction, they are not physically connected. If one body is here, the other body is here. They are not physically connected. If they are physically connected, that is called conduction process. If they are not physically connected, due to this, some charge is created here. That is called induction process. See how this is. Okay, one important step. If I touch a neutral body, it cannot give me current. The current cannot be flow. Means it can give a shock. But if single charge move, means here see, only negative charge. If I touch this body, then current affected to me. I get a shock. See, if single charge is there, then there current flow. If the body gets neutral, then there is no current. Okay. This is the process of induction. Now we discuss about conductor, insulator, semiconductor. What are these? Conductor means in which the charges are easily flow from one end to the other. Means it is a material through which charge can easily move. It conducts electricity. Means current can pass through this. Example, aluminium, gold, etc. All metals are conductors. Graphite is non-metal, which is a conductor. You already know in 10th class. Next, insulator, through which it cannot allow any charge to flow through it. Means it can resist the charge. Okay. Example, wood and fiber, plastic. These are the insulator. Next, semiconductor, the material in which the resistance lies in between conductor and insulator. Means here at high temperature current flow, charge flow, but at low temperature charge will not flow. At high temperature it just acts like a conductor, but at low temperature it just acts like insulator. That is semiconductor. Example, silicon, germanium, carbon. Okay. Now we discuss about Coulomb's law. Okay. Coulomb's law states that the electrostatic force of attraction or repulsion between two charges is directly proportional to the product of their magnitude of charges and inversely proportional to the square of the distance between them. Okay, see, this is a charge Q1 and this is a charge Q2. See, in these two charges there is some force. It may be attraction if both are opposite charges. It may be repulsion if both are same charges. Let I take Q1, Q2, both are positive charges. Means the force of repulsion exists. See, due to Q1 it can repel the force, due to Q2 it can also repel. Repulsion force exists. If both the charges are separated by a distance r, according to Coulomb's law, the force is directly proportional to the product of their magnitude of charges. Means F proportional to Q1 into Q2 and inversely proportional to the square of the distance between them, proportional to 1 by r square. This is Coulomb's law. If I can write it in Q1 Q2 by r square, is there any problem? If I move this proportionally constant and make it equal, then I can write F is equal to beta into Q1 Q2 by r square. Beta is a proportionality constant. You all know, if I move the proportionality symbol to equal symbol, one proportionality constant is multiplied, that is beta. Then what is beta? Beta is 1 by 4 pi epsilon. What is epsilon? It is the permittivity in medium. It can also write it 4 pi epsilon 0 into epsilon r. Epsilon 0 is permittivity in vacuum, epsilon r is relative permittivity. What is permittivity? See, in between these two charges there is some space. The space content may be free space, मतलब इसमें एयर हो सकता है, वाटर हो सकता है, कुछ भी, जो कुछ भी इसमें आता है, मतलब एक मीडियम. So if there is some medium, then the relative permittivity will change. See, epsilon r value is 1. Epsilon r value is 1 for vacuum, means free space. Only epsilon 0 is there. So I can write it F is equal to beta means 1 by 4 pi epsilon 0 Q1 Q2 by r square. Epsilon 0 is permittivity in vacuum. Its value is 8.854 into 10 to the power minus 12. Okay, what is its unit? See, epsilon 0 is equal to Q1 Q2. 4 pi has no unit because it is a constant. Take it F, this is r square. Okay, you all know charge has unit coulomb into coulomb. It's coulomb square by force unit Newton into distance unit meter. So its unit is coulomb square Newton inverse meter to the power minus 2. Okay. Then what is its dimensional formula? See, dimensional formula Q1 into Q2 means Q means charge. Q is equal to IT. We all know. What is Q is equal to IT? You all know. In 10th class also you know. I means ampere. Current. Its unit is ampere. A1 time T1. Okay. A1 T1 Q1 हो गया, A1 T1. Next Q2, it is also A1 T1 divided by, what is the dimensional formula? Is M1 L1 E minus 2 in the first year we know. Then is meter square means L2, solve this, A2 1 minute. See, this is L2 T2 divided by M1 L3 T minus 2. Okay, it is denominator, take it to denominator, M minus 1 L minus 3 T E minus 2 L. This is denominator. If I take it denominator, T to the power 2, T to the power 2, T to the power 4, T to the power 2. This is the dimensional formula of epsilon 0, permittivity in vacuum. Clear? Okay. Oh, 1 minute. The beta value for MKS, we know F is equal to 1 by 4 pi epsilon 0, Q1 Q2 by R square. Okay. For SI, if I take it for CGS, F is equal to Q1 Q2 by R square. Why? Beta value is 1. Okay. Now 1 by 4 pi epsilon. Putting the value of epsilon 0, 8.85 into 10 to the power minus 12, 1 by 4 pi epsilon 0 is equal to 9 into 10 to the power 9. Okay, putting this, F is equal to 9 into 10 to the power 9, Q1 Q2 by R square. This is the Coulomb's force. Clear? Okay. This is in scalar form. Now we discuss Coulomb's force in vector form. See. If Q1 is placed here and Q2 is placed here, the position vector is R1 vector, this is R2 vector. Due to Q1, it exerts some force in this way. This is force in second body due to the first body, means F21. Okay, force in second body due to first body. The distance from first body to second body, this is R12 vector. Okay, see, using triangle's law, I can write R12 vector is equal to R2 vector minus R1 vector. See, R1 plus R12 is equal to R2 vector. Then R2 vector is equal to R12 vector is equal to R2 vector minus R1 vector. Okay. Now F21 vector is equal to, according to Coulomb's force, 1 by 4 pi epsilon 0 Q1 Q2 by R square, means R12 square. As I taking it vector form, I can write a unit vector R2 cap. Unit vector, what is its magnitude? 1. Then I can write 1 to a unit vector C. A cap is equal to A vector by magnitude of A vector. You know, putting this value 1 by 4 pi epsilon 0 Q1 Q2 by R12 square into R12 cap, R12 vector by R12 magnitude. Is this possible? Okay. See, 1 by 4 pi epsilon 0 Q1 Q2 by R12 of 2 into R12 vector. Okay. You already know R12 is what? R2 minus R1. Similarly, if due to second body, the force exerted in the first body, means in this way, F12 vector. Okay, the distance is R21. See here, R21 is equal to R1 minus R2. Okay, same vector addition formula, R11 vector minus R2 vector. See, the same formula. Here also F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R21. Similarly, just change R12 change to R21. What is R21? This is R1 minus R2 is the same. This is minus of this. So I can say F12 vector is equal to minus of F1 vector. Means okay. That means, see, if these are two charges, due to Q1 the force existed in this way, F12 vector, and due to Q2 the force existed in this way. See, the direction is different, but the magnitude is same. See, here the force direction is this one, and here the force direction is this one. This is opposite direction, but the magnitude is same. This is the vector form we already discussed about Coulomb's force. Now, what is superposition? Okay, superposition theory. See, a system having a number of charges left. This is Q1, Q2, Q3, Q4. There are 4 charges. If there are number of charges in a system, see, in here there are 4 charges, Q1, Q2, Q3, Q4. The force experienced by all these charges is equal. The total force experienced by these charges is equal to the sum of the individual forces. Means, see, in Q1, Q2, there is some force experienced in Q1. Electrostatic force means here 1 by 4 pi epsilon Q1, Q2 by R square. If there is one charge, if another charge is placed near this, some force of attraction or repulsion, obviously plus charge repel to another plus charge and minus charge attract to the plus charge. Here see, if all are positive charge, due to Q2 there is some force experienced, that is F21, plus due to Q4 in this way the force is F41, force is a vector quantity. Due to Q3 there is a force F31. That, see, F31, F1, F41. The net resultant force is F vector. Okay? It says F vector is equal to F21 vector plus F31 vector plus F41 vector. Okay? Already you know force formula. 1 by 4 pi epsilon 0 Q2 Q1 by R1 square plus 1 by 4 pi epsilon 0 Q3 Q1 by R1 square plus 1 by 4 pi epsilon 0 Q4 Q1 by R1 4 square. Same common, take common 1 by 4 pi epsilon 0 means F vector is equal to 1 by 4 pi epsilon 0 Q2 Q1 by R1 square plus Q3 Q1 by R2 3 1 square plus Q4 Q1. Similarly, we discuss about dielectric constant. Or it can denoted by K. Let's see. We already discussed in previous class force. A means air, free space. 1 by 4 pi epsilon 0. Let's take magnitude. 1 by 4 pi epsilon 0 Q1 Q2 by R square. Already we discussed. Epsilon 0 is permittivity in vacuum, and for medium it's 1 by 4 pi epsilon 0 into epsilon r Q1 Q2 by R square. See, epsilon r is relative permeability. For a medium, the relative permeability is not equal to 1. For vacuum, it's 1. That's why I don't write in epsilon r, because putting the value 1, it is 1 by 4 pi epsilon 0. Okay, see, if I taking the same charges, Q1, Q2, in both the cases, here the medium is air and here the medium is there is a medium, any medium, it may be water, oil, anything. Okay. Let divide force at air by force in medium. See, putting the value 1/4570 Q1 Q2 by R square by 1/4570 Q1 Q7 R Q1 Q2 by R square 1 by epsilon R. You get 2 numerator and epsilon R. Okay, this is called K. See, here the definition comes. Now we discuss about dielectric constant. Or it can denoted by K. Let's see. We already discussed in previous class force. A means air, free space. 1/450. Let's take magnitude. 1/450 Q1 Q2 by R square. Already we discussed. The random zero is orbit between vacuum. And for medium, it's 1/450 into epsilon R Q1 Q2 by R square. See, epsilon R is relative permeability. For a medium, the relative permeability is not equal to 1. For vacuum, it's 1. That's why I don't write in epsilon R, because putting the value 1, it is 1/450. Okay, see, if I take in the same charges Q1 Q2 in both the cases, here the medium is air and here the medium is, there is a medium, any medium, it may be water, oil, anything. Okay, let divide force at air by force in medium. See, putting the value 1/4570 Q1 Q2 by R square by 1/4570 Q1 Q7 R Q1 Q2 by R square 1 by epsilon R. We get 2 numerator and epsilon R. Okay, this is called K. See, here the definition comes. See, for dielectric constant, any dielectric constant of a medium is defined as the ratio of force exerted between the two charges. Let there are two charges, the force experienced by the two charges having some distance in free space to the force exerted by the same two charges at same distance in a medium. Again I said this definition. Dielectric constant of a medium is defined as the ratio of force experienced by the two charges having some distance in free space or in air to the force experienced by the same two charges having same distance in medium. Clear? Okay. See, there is a problem in book. Now we discuss what is charge density. Density means what? Mass by volume. A bucket having some water, its volume is the water contained in that bucket. Similarly, the charge contained in a system is called its density. It is of three types. One is linear charge density. Second one is surface charge density. And write it in short form, charge density. Then third one is volume charge density. See, what is linear charge density? Linear charge means if the charge lie in one line, means in a single line conductor. Okay, this is a wire. Here current flows. If I find the charge density in a single line, it is called linear charge density. See, for linear charge density, it can symbolize lambda. Means lambda is equal to I see del Q for del lambda is equal to del q by its length means del L. Okay, see, this is del L. Okay, for a huge section, this is a small section. For a huge section, we can write del q is equal to del lambda into del L. For a point, I can also write del q is equal to limit del lambda is equal to limit del L tends to 0 del q by del L. For a point charge, okay, I can write it to dq by dl. Lambda is equal to dq by dl. If derivative goes to there, then it can become integration. So q is equal to lambda dl integration L. What is L? This is the line integral. Okay. Next, surface charge density means, see, surface charge density is denoted by sigma. Then sigma is equal to del q by del s. See here. This is a rectangle. It may be rectangle, square, anything. See, in the surface there are number of charges. If I find the charge density here, then the formula is sigma is equal to del q by del s. Similarly, from here, again I know for point charge dq by ds, dq is equal to sigma into ds, q is equal to integration of sigma into ds. See, here this is surface integral. Surface integral means we integrate it to the area wise. For double integration sigma ds. One is length, one is breadth. That is why double integration sigma into ds. For volume, it can be represented by rho. See, I can write it. Rho is equal to del q by del v. Here see, this is change to volume. First case is line integral, so I take del L. It is for second case, it is surface integral, means I take the surface. In volume integral, I take the volume. Okay. Similarly, dq by dv, q is equal to integration of rho into dv. This is volume integral, means triple integration of rho dv. Okay, clear? Okay, thank you. This is up to electrostatic. In the next class, I explain about electric field.
That's caught in the crossfire.